triangle. It's about as straightforward as it gets. So you have your wall, and then you have your floor, and then what do you have leaning up against it?
A ladder.
A ladder. So there's your picture, right? So then what are the two words that I wanted over on the right?
No and want.
Know and want. Right? So let's label some of this here. How long is the ladder? 5 feet. We know it's 5 feet, right? And it slips away, and so that its base moves away from the wall at a rate of 2 feet per second. So we need to label some things on this. What are we going to label? We need to label some things. What are we going to label? What do we?
X and Y.
X and Y. X represents what?
The base.
Base from what to what? With the base of what?
The base of the ladder to the wall.
Yeah, so this distance right here, we'll call that base, B. And what are we going to call this?
H.
We'll call it H. So if we have those labels, you have to do a few things concurrently here. What do we know? If we've labeled that, what's one thing we know? Yeah, Noah.
The base of the ladder is moving away from the wall at a rate of
2 feet per second. So if we use that, the moves at 2 feet per second, what was that? How is that going to be notated with the letters that I have up there? dB, dt is what? 2. Okay, great. Excellent. Do we know anything else? Okay, what do we want? What do we want? How fast will the top of the ladder be moving down the wall? So what do we want? dh, dt, when what?
The base is 4 feet.
When b is what?
B equals 4.
When b equals 4. So now we want to write our equation, right? We're trying to write an equation where we link what we know and what we want. So we're trying to link b and h. What's the equation going to be?
X squared. Or
No, b squared, yep, plus
a squared
equals
5 squared.
5 squared. And then we're going to differentiate with respect to what? We're differentiating with respect to what? T. We're differentiating with respect to t. So let's do that differentiation. What's that differentiation going to be, Lindsay? You don't know? Arvin, what's it going to be?
2 b
Times
2 will
dB dt. Yeah, don't plug it in yet. It will be. Don't. I just want the different. Do one thing at once. dB dt plus
8 or 2h
2h.
2h.
No, dh dt equals what?
0.
0. There. 10 0. 0. Say 0. What can we simplify out of that? Yeah, get rid of the 2's. So what are we left with? We're going to b times dB dt, right? Plus h times what? dh dt equals 0. Which is the one we want? We want what? We want dh dt, right? So if we want that one, we have to plug in values for all the other ones, right? So the first thing is when b is 4. So where can we plug that in? Plug that in for b, right there. So we have 4. Do we know what dB dt is? Oh yeah, we know what dB dt is. That's right there. So what is it? 2 plus h times dh dt equals 0. So what's the one thing we still have to replace in there? We need that h, right? So we need h when b is what?
4.
So we know that's 5. That'll be 4. So what's h going to be? 3. So some of these are set up really nicely. Are they always set up really nicely like that? Not always. You might have to use the Pythagorean theorem to find the h. But in this case, what's the h going to be? So we want h when b is 4, right? So what's that going to be?
3.
Therefore, h is 3. So what do we end up with? 4 times 2 plus 3 times dh dt equals what?
0.
So 3 times dh dt is equal to negative what? 8. So dh dt is going to be negative 8 over... And what's the units on this? What are the units?
Feet per second.
Feet per second. And should it be negative?
Yes, because it's going down.
Because it's going down. Absolutely. It's going down, so it's negative. That's one thing you have to be careful of on this. So in this case, b was growing, so it's positive. But h will be shrinking, so dh dt is going to be what? Negative. How do you feel about this one right now? How do you feel about this one? 0 is you're totally lost. 5 is you could just... So what's going on here? There's a pulley, right? And there's this dock, and then there's this point, and that right there is the bow of the boat. So if I draw a triangle here, which thing is 10? Which thing is 10? The height. This is 10, right? So where's the pulley? The pulley is... There's the pulley, right? Do you agree with this?
Yeah.
Okay, so it's a triangle again. Yay, at least it's still a right triangle. That's kind of cool. So there's our picture. What do we know? Well, we need to let's give some labels here first. What's one thing we need to label? What's one thing we need to label? Like the boat is from the dock, right? So what do we want to call that? X?
Yeah.
X. Generally speaking, everybody, side to side, call it X or B for base. Okay. So what do we know and what do we want? What also changes here? There's one other side that changes, right? Is it the same amount of rope all the whole time? No. So what's changing? The what of that triangle? The hypotenuse of that triangle is changing in length. Do you agree? We need to give that a letter. What do we want to call it?
Z.
Call it Z. We call it R. Let's call it R for rope. Let's just call it R for rope. But it could be Z. Again, it doesn't matter as long as you label it. So based on these letters, what do we know? What do we know? D of R. dr, not D of R, dr dt is equal to what? Careful, not 20 feet, negative 20, because it's getting shorter. You're pulling it in, it's getting shorter, right? And you don't have, you can put the units in now if you want. I only require units at the end. I'll only require it earlier if it becomes a problem for you and you don't put them in at all. What do we want? What do we want? What do we want? D what? We want dx dt when what? When r equals 125. When r equals 125. Do you agree with that? Yeah. When r equals 125. Okay, so let's write our equation now. What's our equation going to be? It's really nice. What is it? Come on, who can do it? What's our equation?
X squared plus 10 squared.
Yeah, x squared plus 10 squared is equal to r squared. So now we differentiate with respect to t. Mark, what's the derivative of this with respect to t? 2x times what? Yep. Plus what? 0 equals times dr dt. You're going to do this a lot. And then what cancels? The 2's. So if the 2's cancel on this, we're left with closer to what we want, but we want dx dt. Here's dx dt. So if we want dx dt, we need values for all the other things, right? Do we have some of that already?
Yes.
R is 125, so it's going to go right there. Okay, so we have, oh, do we have dx dt? Sorry, we wanted dx dt. Do we have dr dt is what I mean, sorry. Do we have dr, I'm sorry. Dr dt is right there. So what do we get? X times dx dt equals what? Negative 20 times 125, right? You agree with that? What's the last thing? If we want dx dt, what do we have to solve for? We need this right here. Do you agree?
Well, wait.
We need x. We need the x value.
I mean, that's the same thing, but just like...
What's the same thing?
Yeah, never mind.
Am I okay? Oh, I flipped the sides?
Yeah, just in case other people might get...
Yeah, you flip negative 20 and 125.
Oh, yes, please. No, that's actually really good. So the R is 125. Thank you. And that's negative 20. That's actually important. Thank you. You're right. It is numerically the same thing because multiplication is commutative. But if you're trying to follow this, little things can matter. Have I told you about what I think and believe is the worst word to see in a math book? Have I told you this before?
Therefore. Always?
No, actually, always is a regular word you're going to use. No, like,
therefore.
Nope.
Oh, clearly.
Simple and clearly. Yeah, you guys have heard me say this before. Like, if you ever see a math book that says clearly the answer is 7, like punch the book in the jugular, okay? Here's why. Here's why, everybody. The reason that word sucks to see in a math book, either you're reading the work and you understand it, and you don't need the book to tell you that, right? You don't need the book to be like, good job, good job. Or you don't know what's going on, and then the book just made you feel worse, right?
Yeah.
Like 50% of the time when something says clearly, like the work is so close to you, does that mean it's easy to see? No, it's not. So whenever you see a math book that is like, clearly the answer is 5, you're like, I hate you, right? There are math books you will see that are overly reductive and like skip steps. In the answer keys to the calculus book I have, you generally see, and this is not just the calculus book I have, but R is what? We need to know what X is when R is what? Need X equals when R equals? Well, we know that 10 squared, right? Plus x squared is equal to 125 squared. So x squared is going to be the square root of 125 squared minus 10 squared. So we take that and we put it there, and we end up with dx dt is equal to negative 125 times 20 all over the square root of what? 125 squared minus 10 squared. Now, would you have to use your calculator to find the nice answer to that?
Why is it negative 125?
Because I just put the, I'm sorry, I just bounced the negative to the front of this.
That's fine.
Again, no, but do you see what I mean?
Yeah.
Like, if I did that 10 times, little changes like that, it trips up, it compounds itself, but there, that negative is there. Should it be negative?
Yes.
Should the answer be negative?
Yeah.
Why?
Because it's getting
Closer to, the rope's getting smaller and the boat's getting closer to the dock. Now, would you need a calculator to find the decimal approximation for this? Yeah. This right here, if you got to this, I would give you full credit just for that. You might try to, if you have a calculator on a test for a question like this, there is no glory in simplifying this by hand. Because 125 squared, I'm not going to, minus 100, like maybe it's a perfect square? I don't know. Side note, go see Hidden Figures, everybody. Go see it. Go see it. It's amazing. It's fantastic. When I taught you implicit differentiation, what did I tell you to do? Do substitution first, right?
Yeah.
It forces you to remember to use the product rule in this case. So for example, when you did area is equal to 1/2 base times height, you could write it as area is equal to 1/2 b in terms of t times h in terms of t. If that helps you remember, you have to use the product rule. You are differentiating Alex and Andrew with respect to time. So both of them are getting differentiated with respect to time. So you have to use the product rule. You use it carefully. Okay, so let's find another good one. Is it a triangle? Right triangle?
Yeah.
Something like this? Something like that?
Yeah.
What did you label on it? What did you label on it? Yeah, what's one thing you label? What's one thing,
The
Noah?
base is 3,000 feet.
And that stays the same the entire time, right?
Yeah.
So what's another thing you label? Anybody label anything else? Yeah, Arvin, what'd you label? H?
D of H over dt.
Well, hold on, don't, yeah, so this, you label that H right there, right?
No, that's 4,000.
No, it's when, you're looking for something that happens when it is, so that is H, that is changing, so that's H, okay? So I'm saying, I just wanted you to draw a picture and label, not come up with anything.
H, and then I said next to it D of H over
Yeah, hold on, I just want the picture and the labels first, and then we'll come up with no and want. And then L right here,
Yeah.
there's something else that you need to measure, or say the label, the angle, so you need to call this what? Let's call it theta. You need those things right there. You need those things. So now, let's go with what we know and what we want. So what's one thing we know? What do we know?
dHdt equals 880 feet per second.
dHdt is equal to 880 feet per second. Anybody know how fast that is in miles per hour, by the way? 800. Anybody know?
That's like a lot. That's like
As far as I remember, 80 feet per second is like 65 miles an hour, I think. So it's like 700 miles an hour. It's fast. Okay. What do we want? What do we want? Nope. How fast is the camera angle, the camera elevation angle changing? We want d what? What do we want?
theta.
We want d theta dt when what?
H equals 4,000.
4,000, right? So here's the 4,000. Sorry. Here's the thing. What's the next step? Don't do it, but what would the next step be? You guys do the picture, and then you write the equation, right? But to figure out what the equation is, you need to link together what you know and what you want. So in this case, you're trying to link together h from the h dt and the what? Theta. You need to link together h and theta. What function are we going to use to link together theta and h? What function are we going to use? David?
Sine.
We could use sine, yeah, exactly. So you know that sine of theta, good job, is equal to what? What is sine of theta equal to? What's the ratio for sine? Opposite over what?
Hypotenuse.
Opposite over, so you could use sine, and that would be sine is h over what?
H over L.
Now that's three variables, right? You can do it this way, it's fine, but could you make a different choice? You surmise properly we need a trig function, that's the important part, David, but is there a trig function that might be a little bit easier for us to use? Yeah.
Cosine.
What?
Cosine.
We could try cosine, so what would the equation for cosine be? Cosine theta is equal to
Jason over hypotenuse, so 3,000 over L.
3,000 over L.
It could actually be easier to just use.
What's the third one you could use? You could maybe use tangent theta, and what would tangent theta be?
Opposite over Jason.
So that would be h over.
3,000.
Now in terms of these three, each one we could use. Which one do you want to use? Option 1, 2, or 3? Sine, cosine, or tangent?
10.
Yeah, let's try tangent and see what happens here. Let's try tangent. Now the reason I like tangent is because the h is on top. We don't have
It gives
to.
us the height.
It's not bad, right? So now though, now we need to take the derivative of both sides, right? Now we do the derivative, but we have to do it in terms of what? T. Do it in terms of t. Can someone stop writing, everybody? Hands up. Everybody look. Stop writing. Stop writing. What's the derivative, Andrew, in terms of t? Can you do the derivative of the left in terms of t? What's the derivative of tangent theta in terms of t? Andrew, do you know what it is? So you know it's secant squared times what? Of theta, times what? Because you need to use the chain rule, right? Equals 1 over 3,000 times what? Times what? I'm doing the derivative, dh dt.
Oh, yeah.
That 1 over 3,000 is just the coefficient. So I've taken the derivative. We need to stop here. Do you understand what we just did right there?
Wait, we're not going to use the quotient rule for that?
No, we don't need to. It's 3,000 is just 1 over 3,000. It's just a constant in the front. You could use the quotient rule. That's overkill. You don't need to use the quotient rule.
So that 3,000 isn't going to turn into 0 because usually
It does if you use the quotient rule. You don't need to use the quotient rule. What's the derivative of a times x? A times dx dt if you did it in terms of t, right?
Why did we do 1 over 3,000?
Because 3,000 is in the denominator right here. This is the same thing as 1 over 3,000 times what? Times h. All I'm doing is that derivative. The 1 over 3,000 is just along for the ride.
So,
But the h turned into a 1, right? And that's
The h turned into dh dt, yes. The derivative of h in terms of t is dh dt. The derivative of q in terms of t is dq dt. Yes.
So we multiply that and put it on top, or do you want to next to it?
yeah, I thought it would be then times dh dt times.
Hey kids. Blah times x. If you differentiate that with respect to t, what is it?
Blah.
Blah times dx dt. Do you agree?
Yeah.
Okay, so what's 1 over 3,000 times h when you do the derivative in terms of t? What's that going to be? 1 over 3,000
Times DHT.
times dh dt.
Okay.
Do you see that, everybody?
Yeah.
Okay.
Dividing by 3,000 is the same thing as multiplying by 1 over 3,000. The 1 over 3,000 is just along for the ride. Which one are we trying to solve for here? Which variable are we trying to solve for? We want d theta dt, right? So if we want d theta dt, what are we going to have to find?
DHDT.
And
Theta.
theta, right? Do you agree with this, everybody? Do we know one of those? Which one do we know? I'll zoom back out here. Which one of those do we know? We know dh dt. We know this one, right? So what do we have here? Secant squared theta times d theta dt is equal to 1 over 3,000 times what? 880. What's the last thing we need? We want the d theta dt, so that can stay there, but what do we need? We need theta. We need this one. We need theta. So we want, what do we want? We want theta when what is true?
When h equals 4,000.
When h is 4,000, and what always is staying the same? The base is always staying the same, right? What is that?
3,000.
So the base is 3,000. So what's the triangle then?
So 10,
It's going to be 3,000,
4,000.
4,000, right? So, yeah, we can use it. We're not going to need, that is 5,000, but we don't need it. The reason this triangle is really nice is because if we used one of the other triangles, we would need to use that 5,000. But in this case, do we need to use that 5,000?
No.
No, because you know that tangent of theta is equal to what? 4,000 over, which is the same thing as writing 4 over 3. If you want theta, what function do you now use? Tan inverse, exactly. Tan inverse of 4 over thirds is theta. Do you agree with that?
Use tan inverse, I'm sorry.
Because we know tangent of theta is equal to 4 thirds.
So
We want to find out what angle has a tangent of 4 thirds. So use tan inverse. Use your calculators right now and tell me what tan inverse of 4 thirds is to 3 decimal places.
easier if you told us one way or another.
Well, you can use I would like you to stay in radians, but you are free to use degrees on these.
As long as you do.
Yeah, as long as you're consistent and you say what unit you're in. So if we want to isolate that,
Radians, you just put in the
Yeah.
radian number in that.
yes, exactly. You just stay in one. I would like you to stay in radians.
Yes.
D theta dt is going to be equal to 880 over 3,000 over secant squared of tan inverse of 4 over 3.
You see, that's what I was asking about the 880.
Yeah.
Multiplying it into the
Yeah.
1/3,000. That's what I was asking.
Oh, yeah. You can do that. Sure. Yeah.
Does it clean it up?
So type that into your calculator and tell me what answer you get right there. Type that into your So you could, if that's 1 over cosine, one way to do this would just be to write cosine squared of tan inverse of 4 over 3 times 880 over 3,000. What is it? Anybody have an answer? What do you,
0.176.
0.176? That'd be radians per what? What's the time unit? Second? Anybody get it in degrees? Anybody get it in degrees? No? That sounds about right. I think that sounds right. How would you convert that to degrees if you had 0.176? What do you multiply by?
Pi over 180.
Close.
180 over that.
180. It goes bigger. So what's that going to be? If you do 0.16 times 180 over pi, someone do that for me and tell me what it is, just so we have another answer. What is it?
43.54.
43.54?
We got 10.08.
That should be, yeah, I think it's smaller than that. 10 point what?
Oh, wait.
Degrees per second? Yeah. I think that's right. Let's see what the